Today, what I had in mind is this will be sort of a continuation off of a couple weeks ago's presentation on dplyr. Today, I'll be introducing the basics of data table, but it's mostly going to be like a cursory look and then mostly emphasizing actually the dtplyr package, which is designed to sort of get the performance benefits of the data table package while using dplyr syntax. I also want to mention that Gio had done a really good presentation on this. It was a while back. It was like 4 years ago at this point, which is surprising. Time goes really fast. But that goes into more details on the data table package maybe, and it's a great reference in case you want to learn more. But yeah, we'll be sort of going through this resource by Rafael Irizarry. And yeah, he starts with the motivation that I just described, which is that like maybe you're familiar with the dplyr package and that's good enough for you for like manipulating data and you're comfortable with that sort of syntax like I am. But data table is sort of designed for like performance. So it'll be faster and then it's also more memory efficient in many ways. So that's sort of like the motivation for getting into this package if you already know dplyr or you don't, or you're just familiar with base R. So I guess we'll just go through some of these basics. So maybe the first function is just like this set dt function, which is just converting whatever sort of data frame like object you have into a data table. So importantly, one of the performance benefits here is that you're not making a copy that with a different data type. You're actually just like translating the original data into a data table. So that's how you sort of convert things into the format for working with data tables. And then we can get started with sort of selecting columns specifically. So with data table, it's pretty straightforward. It's really just, it's like a normal data frame, really. At least you can use the same syntax you use for normal data frames, unlike the select command from dplyr. As an alternative to that, you can sort of do something similar to dplyr without using quotes around your variables. So if you use this dot notation, that allows you to do that with the data table package. So yeah, that's selecting columns. If you want to change columns, so recall back from dplyr, there's the mutate function where you add like the column by name and then you describe the value that you want it to have. This is where it sort of diverges a little bit. Data table uses this special syntax with a colon equals. So it's similar in that you're still defining a new column called rate, but it's more efficient memory wise, and I'll get to that in a little bit. It's actually towards the end of today, we'll be talking more about memory with data table. But briefly, it updates by reference, but I'll describe more about that towards the end. So yeah, you can also not use quotes here around these variables to indicate you're selecting columns. So somewhat similar other than this colon equals syntax. And the other thing you might notice is that there's no like murders equals murders, all the syntax here. This updates in place. So you don't need to do an assignment here. It gets a little bit more complicated when you want to do multiple columns. The syntax is a little bit weird. This is one of the reasons I haven't really gotten into data table, because to me, the syntax is not super intuitive, despite like all the performance benefits of the package. And so that was actually one of the reasons I was interested in this dtplyr package, which I'll talk about in the end. But yeah, there's this colon, you can use the colon equals like it's a function and then define column names as the parameters. So, and you can do as many columns as you want with the syntax, but a little counterintuitive, but memory efficient. And this is just how you can do that. So they do describe more of this stuff about memory, references versus copy. When I read it, I thought it was a little bit misleading, the way they describe how the memory works. So I'm going to actually skip over this section and then we'll talk about this in the end. But basically, the overall like takeaway, I guess, is that like data table in R and in dplyr, a lot of times copies are made of input data and stuff like that. And so every time you like do something, you might have to create a copy and then it is extra memory used, when in theory you don't have to do that. So data table tries to avoid unnecessary copies, essentially. That's the big picture. In terms of filtering rows by conditions, so dplyr, we have that filter function where you take the data frame and then the column, the condition actually. And here's where data table is maybe a little more similar to base R or data frames, where it's sort of like, other than the fact that rate is not quoted and it's referring to a column name. Other than that, it's somewhat similar. And so this is another area where I don't know why this confuses me, but personally, is that like earlier we would use the colon equal syntax to assign new data to this murder's data frame. But here we're not assigning anything new. We're just printing sort of like a subset of the data. So I don't know, that's confusing me, but just keep in mind sometimes you're sort of referencing the original data and sometimes you're actually making new assignments depending on which operator you use. But we can also combine sort of filtering by rows and selection of columns using the same syntax for both, right? So this was the earlier syntax we had introduced for selecting columns. We could also do these as in quotes without this dot syntax. And similarly, we use the same syntax for the rows. But yeah, you can do, I think one of the aims with data table other than performance is like things can be very succinct. So very little code actually written to execute something relatively complex in some cases. So a lot of times you can combine things into a single line. Unlike dplyr, where if we were to do this, we have to have two separate verbs, one for filtering by rows, and then the other for filtering by columns. A little less code there. So there are some exercises. I'm not going to go through these, but in case you're interested, this is always an option to just make sure you're familiar with the basics. Now, there's a lot more you can do with data table, a lot more complex things. Like you can group, do operations that are grouped. You can do pretty much anything you can do with dplyr as advanced. And the syntax is different, but I won't cover that because my main emphasis will be this dtplyr package, which I have in case you want to reference this, I link this in the rstats Google Sheet. So the link for both the markdown and then the HTML, I'm going to go through this HTML. Since GitHub can't render it, I just downloaded it and we'll go through this as the sort of the second section of this session. So yeah, I guess the approach here is that like, let's assume you like dplyr, but you want to get the performance benefits of data table. So there's this dtplyr, very similar package name, but the overall idea is, yeah, like I said, you get performance from data table, but you can actually write dplyr code pretty much as is, and then it actually will get translated into data table code and executed, which can make your code faster. It can lower the memory requirements, and you really don't have to change the code very much to do it. So as a sort of caveat, I'll say that I sort of forgot about this package and I haven't really used it thoroughly. So I'm not sure I haven't tried super complex operations to see if there's a perfect translation for everything in dplyr. Like I'm suspecting that certain things would be maybe not implemented, but haven't tested. Anyways, to go into the background of, I mean, you can sort of use dtplyr as a black box if you want to, but I find it like in this session I'll talk a little bit about sort of memory allocation and R, both base R and then dplyr and data table to sort of give a background as to like what's more efficient and make sure that you don't accidentally. There's some unexpected behavior you can use if you're using sort of fully optimized dtplyr code. So we can go into sort of the background, sort of introductory memory concepts in R. So in general, I would say in R, unlike many other languages, sort of it's almost designed to protect you from accidentally modifying existing objects. And that can be at the expense of memory efficiency. So by the way, when you're using the dtplyr package, typically you'll load like these three packages, the dplyr, data table, and then dtplyr, of course. But in terms of the thing I'm talking about with memory, let's say you create a data frame or a table or your favorite type of data frame, and then you assign a new variable. Let me zoom in, actually, this might be a little small. You assign a new variable to the original data frame. So in many languages, this would be a reference to the original object, and you're not actually making a new copy. So with R, you're still not making a new copy yet, but the second you modify this new variable B with a new column, then it makes a full copy of A and then adds the column. So that's to protect you from modifying this original data frame. So if we print the original data frame, it still has this one column called X, just as we defined it. But in many languages, it would actually have two columns. It would have the one you added to B, which is just might be a reference to A. So this is sort of behavior that's different in R than other languages. And by the way, this applies to pretty much any object in R. There are some exceptions, but vectors, lists, data frames, they all have this copy on modify behavior. And I think dplyr is sort of the same general, it's almost like the same philosophy really where they make an effort not to modify the original data if you do operations on it. So similarly, if you start with a very simple data frame and dplyr, and then you add a column, then this data frame B is of course going to be different than. So I mean, you're not adding a column to A here. You're modifying it just to B. And with a mutate and dplyr, one of the drawbacks is that, like, I mean, in order to get this behavior, you have to fully copy A and then add a new column. So you have like almost double the memory usage here. So I mean, there's a reason they wrote it this way. It's because it's maybe a little bit more intuitive. It's sort of just based on the philosophy of what you're trying to achieve with the code. But surprisingly, really, I mean, like any dplyr verb, we're talking about mutate here, but like if you talk about select is a little bit more surprising, right? Because, well, maybe not. Select, when you're selecting columns, it's also copying those columns from the original data frame. And so you have sort of two instances of each column that you're selecting. But pretty much any verb behaves like that is what I'm trying to say. And so that's not optimal in terms of memory usage. And so with data table changes that. So we had talked about earlier, if you start with a data frame and then you use this colon equals syntax, you are modifying the original data frame. You're not making a copy. You're simply leaving the data as it is and then adding a new column. So that's sort of like the minimum way you can like use the minimal amount of memory for what you're trying to do. It's much more efficient, especially when you're working with big data frames. Then they also have a bunch of functions that start with like this set. So I talked about set dt earlier for like defining a data frame without making a copy. Set names is another one. So normally you would just do like call names of a equals x new, y new, or whatever. So pretty shockingly, if you do that with call names, it does copy some of the underlying data, which I was really surprised to hear about. So I thought you were literally just modifying the column names, not making, apparently it makes like shallow copies of some of the columns and stuff. But anyways, lots of these data table functions that start with set are designed to modify the underlying data and not make new copies. So yeah, in this example, we had added a column in place and now we have two columns. Yeah, I had mentioned set dt already. So, I mean, that's sort of the background behind how memory behavior is different with data table versus dplyr and base R. So now if we want to talk about using dtplyr, so I talked about the fact that you can use this, like pretend we're coding in dplyr, but now we get the performance from data table. So how do we do this? Well, there's this object called, in this package introduces called a lazy data table. The difference here is that, well, actually, I should just jump into this example because it really shows how it works. So let's just say we take this built-in data set from R. The first step you would do to work with this data as if it's dplyr code is you assign the object to a lazy data frame. So then if you want to do some operations on it, let's say we're trying to find the mean miles per gallon so this is a car data set, right? So the mean miles per gallon for each like number of cylinders that a car can have. So we group by number of cylinders, we summarize, and then we might order it by like the number of cylinders just to have it sorted. So that's dplyr code, right? So this code actually doesn't get, when you're using a lazy data frame object, the code doesn't get executed. It's just sort of tracking which operations will occur. So that's why it's called lazy. It's not actually executing the operations yet. So you can actually, there's this function called show query if you're curious, just to show that like it basically shows the translation of this dplyr code in data table. So this is what it would look like. I mean, the thing's called, internally it's called underscore dt9, but other than that, the remaining syntax here is just data table code showing how you would group by the number of cylinders, you're arranging it, and other things. So generally, the idea is that most of the time this is going to be more performant than the dplyr code, but you don't need to even know the data table code to execute this. So, okay, so I said it wasn't executed yet. To actually get the data frame back I work with tibbles a lot. So if you want it back as a tibble, this is when the actual operations occur. So the second you try to convert it to a different data type, then it executes all the operations that you had on it. And then it does exactly what you expect in usually faster and with less memory. So pretty useful here. We'll mention that there's like I said, I haven't tried it with really complex operations. Probably today I'm actually gonna try some stuff with Visium HD where I have some huge data frames that probably would have been better to do this in dtplyr than dplyr. But anyways, there are some caveats. So I guess the difference between dtplyr and the actual data table code is that dtplyr is intended to behave like dplyr. And so what does that mean? Really, the major case where they are different is like if you use a mutate from dplyr, that actually will by default copy the starting data frame. And I had mentioned that was one of the things that was inefficient about dplyr. But it is intentional, and the reason is that it's still trying to follow the dplyr philosophy of not messing with the input objects. And it's supposed to behave like dplyr code exactly, sometimes at the expense of memory. So that said, you can turn this behavior off, but you just need to know how it works. So let's give an example again. So we have this, again, we're working with this car data set. And the difference here is we'll specify this immutable equals false parameter to lazy DT. And that's saying that go ahead, you're allowed to modify the original object. In this case, A would be a reference to the original object. So if we do basically the same thing as we did before, we make a lazy data frame, we track some operations. And in this case, we have a mutate. Then we convert it back to a tibble. Then if you don't know what you're doing, then it might be surprising to you that if you take a look at the original data frame, it has this new column. So why does it have a new column if we never modify it? Well, we did. We said that because we want to be memory efficient, we are allowed to modify the input object in a way that's inconsistent with how dplyr normally works. So I think just like understand, like I think this can be a useful, you can still get very good performance, like pretty much data table performance, especially if you use this option. Just make sure you know how it works, and that if you want two different data frames that are independent, then probably don't use this option. And so, yeah, so basically this mutate is not making a copy. It is just adding a new column to the original, as we showed here. So yeah, that's what I had for today. I hope like this dtplyr, like this stuff was, I think I'm going to start implementing this a lot more. I know, because I was always wanting something that was like more performant, but I never really got into data table based syntax. I thought it was just a lot to learn, but yeah. Any questions or anything?